Hello everybody, this is the fifth video clip for the first chapter, and this one we are going to talk about the limits at infinity. By limits at infinity, it means that we are going to consider the behavior of the function as your x goes to either positive or negative infinity and see how the function behave, okay, over there, like as your x getting pretty large or pretty small, okay. And also we are going to introduce the so-called horizontal asymptote. By asymptote, it means like the is the same as the behavior like far away, either on the right hand side as infinity or the left hand side as infinity of that function, okay. So it means that that function will like go close to that asymptote, okay, as it goes to infinity or negative infinity. So for example, if you look at this function fx equals to 1 over x, of course, this one your x cannot be 0, right? Okay, so it means that if your x is 1, okay, then your f of x will be 1 as well, okay. If your x getting smaller, you remember, if your x getting small, for example 0.1, then your 1 over x becomes like 10, okay, and then becomes 100. So the curve will go like that. But if your x getting larger, for example, if your x is 10, it becomes a what? 1 over x becomes 0.1. So it will go smaller. And if your x getting larger, for example, 100, then it will go smaller and smaller and smaller. However, because this is a fraction and your top always fixed to be 1. So the fraction will equals to 0 if your top is 0 and your bottom is not 0, right? And this one, your top always 1. So this one can never be 0. So it means that it will just get very smaller and smaller, but it can never goes to 0, okay? So just like pretty close to the line what y equals to 0, okay. And this line can be called the horizontal, okay, asymptote, okay. So this one is the line that as you go far away on the right, your curve, okay, go close to that line. We get. And on the same token, if it is in terms of negative value of x, okay, it will start from what? -1, okay. And then if your x is like negative 0.1, then it will be the same thing, right? But it becomes a negative number, so it will go down, okay. It's a large negative number, so it go deep down, okay. But this one, it will be a bigger, what should I say, a bigger negative number, so it will goes up, okay. For example, it will be negative 0.1, negative 0.01, etc. Okay. However, again, even though it is a negative, okay, for example, this one is -10, okay, it can never go, it can never equals to 0, because again the top is always 1, right? So this one, okay, it will go close to this line y equals to 0. So this one is also, we can call it a horizontal asymptote, okay. So the horizontal asymptote can look at far away from the right, and also far away on the left as well, okay. Okay, but this function, for this function, it just happened to be the same, either go to infinity or go to the negative infinity, the horizontal asymptote still y equals to 0, okay. Okay, so this one is like the thing that we just explained, right? So we are going to saying that as your x goes to negative infinity, your function, okay, your function going close to 0, as you can see from the graph. So we saying that a limit as your x goes to infinity of this function equals to 0. And also the limit as your x goes to positive infinity of this function equals to 0. And sometimes, okay, we may drop the positive sign and then just write x goes to infinity of your f of x equals to 0. So it depends on like the books, and also like sometimes we just forget. Okay, however, if we talking about a negative infinity, don't forget that you still need to put the negative in front of it. Okay, so here what we have is that either x goes to infinity or negative infinity, a function 1 over x will goes close to 0. That's the limit. So by a limit law, we can just what? Raise a power r both sides. Okay, we can just raise a power r both sides. So we got this kind of rule, which is very helpful. Okay, to find a limit of a function. Okay, in terms of x raised to power a number. Okay, so we have 1 over x raised to power r. Okay, either x goes to infinity or positive infinity or negative infinity, it will goes to 0. But the very important condition is that your r must be positive. Okay, your r must be positive. So it means that the large number, the large value will be at the bottom. Okay, will be at the bottom. So this one, it just look like a constant. Okay, over a pretty large number. So I'll just write down this way. Okay, pretty large number, it will go close to what? It will go close to 0. Okay, this is like the behavior, okay, that we obtain from this law. Okay, so for example, if you want to find this limit, okay, we are going to pull out, okay, so the techniques, okay, in order to obtain this kind of term, okay, 1 over something term, the technique is that we are going to pull out the largest power on each top and bottom. Okay, so this is the technique that we are going to use. Okay, so for this one, the largest power is x squared. So we are going to pull out the x squared from the top. So we have 4, we have 1 over x, we got 3 over x squared, we good. And on the bottom, we also have x squared as the highest power, right? So we got 5 minus 2 over x. Okay, and then because your x is pretty large, so it means that your x can never be 0, right? It is a large number. So it means that your x squared can be out. Okay, now the limit can go to apply to each one of them. Okay, for the 4, okay, you just have 4, right? Because it's a limit of a constant. And then here is 1 over x. So we can use the law that we just have, right? So it will goes to what? Like 1 over a large number, it will goes to 0. This one as well, it will be 3 over a pretty large number because it is a square, right? So it will be larger and larger. So it becomes a what? 0 as well. And then at the bottom, this is a 5, the limits, okay? Okay, so the limits will apply to here, and the limits will apply to there. Okay, so the limit of 5 will be, of course, 5, and then the limit of, again, a constant over a large number, so it goes to 0 immediately. Okay, so this one becomes 4 over 5 is a limit of these fractions. Okay, using this kind of uh techniques. Okay, so we are going to apply these techniques to this problem as well. Okay, even though it's like not only contain a polynomial, but it also contain a square root. Okay, however, if it contain a square root, then you really need to be very careful. Okay, so that the thing that you need to careful is that a square root of x squared, it is the absolute value of x. And again, the absolute value of x can take two kind of value. Okay, it can be x if your x greater than or equals to 0, and negative x if your x less than 0. So this means that if your x goes to infinity, you would choose this formula. If your x goes to negative infinity, you may need to choose another formula. Okay, that's the idea. All right, so take a look at this one. Can you see that the highest power of the top is x squared? So this one go to infinity, so you pull out the x square, so you have this left, okay? And this one, even though you see, it seems that x fourth, right, is the highest power, but after taking a square root, it becomes x squared. So your x squared also the highest power. So we have 1, okay? Let me do it this way first, okay? So we have x squared, and then this one also a square root of x fourth, and a square root of 1 minus x fourth, right? Is it? Okay, because you just pull out the x fourth from the square root, okay? So if you're talking about the x fourth, okay, so here, let me do it slowly first. Here 2x squared, and then this one, okay, actually upon the square root, it should be x squared with the absolute value, right? But because your x squared always non-negative, so this one becomes just x squared itself, okay? So it means that you can pull out this common factor, x squared. So we have a square root of 1 minus 1 over x. Oh, sorry, this is x what? X cubed, because here you already have 1x, okay? Okay. So again, your x goes to infinity, so it is not going to be 0, right? So these two canceled. So you end up with this one, and the limit goes directly to each one of them. So the first one is 2 because it is a constant. The second one, again, a constant over a pretty large number. So it goes to 0. And then this is 1 as a constant, right? And here you got also a square root of 1. Okay, but the one inside, it is 1 over a pretty large number, is it? So it is go into 0. So you have 2 over 2, which equals to 1, okay? That will be the limit of these fractions. Are we good? Okay. How about this one? Again, you remember we have done this one before on like the previous video clip, okay? We just saying that, hey, if you just like roughly speaking, if you just plug in infinity to the sign, then we cannot control the behavior of sign of infinity. So what does this mean? You need to think of the other way around, which is a squeeze theorem, okay? So since we know again that your sign, it is in between -1 and 1, and then because your x is going to infinity, so it means that your x is positive, right? So for a positive value of x, okay, I'm sorry, for a positive value of x, you can just divide the whole thing by x, okay? Okay, so this one is valid, and the inequality, no need to switch, right? And the limit, okay, as your x goes to infinity of either plus or minus 1 over x, it is again 1 over a large number. So it goes to 0, right? Either way, positive or negative, because the 0 has no sign. So by the squeeze theorem, we can conclude immediately that for this one, as your x goes to infinity, sine x over x will goes to what? 0. Okay, it will go to 0. How about this one? Okay, how about this one? This one, it seems that if you plug in infinity, you got a square root of infinity. Okay, so a square root of large number is still large. Okay, and then minus and x, which is goes to infinity, right? So it seems to be infinity minus infinity. Is it going to be 0? We don't know, right? Because this one is large, this was also large, but we don't really know how to compare that large amount, okay? Okay, so it maybe goes to somewhere else. So we really need to check, okay? So by checking, one of the techniques is that we just multiply this one again because you have a square root, right? So you think of what? You think of the conjugate, okay? So that we get rid of a square root. Are we okay? Okay. So this one, the limit goes to what? The one on top become x squared plus 4 minus, don't forget that you need a square as well, right? So it will be square plus 4 minus x squared, but then this one still have it here. Okay. So on top you got a limit as your x goes to infinity of 4 over a square root. Okay, and you don't really need to do a factorization or anything, because this one on top is already fixed, right? A fixed number over a what? A pretty large number, right? Added. You see, it's not subtract anymore. Right now it's added, so it will become a larger number. So it's a fixed number over a pretty large number. It always goes to what? 0. So this one, it just happened to be 0, okay? It's not always. This one just happened to be, okay? Happened to be. Are we all right? So how about this one? Okay, this one is something that you really need to be careful. It seems that on top, the thing that is largest, x to the power 1. On the bottom, even though you see a square, but you have a square root. Okay, so it means that this one, okay, on your top you can pull out the x. So we have this, and then on the bottom you can pull out the square root of x squared, so that you got this one. Okay, square root like that. Okay, and as we told you that square root of x squared, it is the absolute value of x, and it can take two kinds of formula. Okay, depends on x is positive or negative. So this one, if we do it pretty clear and neat, okay, we need to have this one carry, and this one change it to be the absolute value of x first. Okay, and since right now your x is negative, okay, so the absolute value of x will use this formula, so it becomes a what? X, and this one just carry on, okay, over what? Minus x, you see, and then this square root. Okay, so now your x and negative x can cancel, because again your x, of course, it's just a pretty small number, so it's not going to be 0, and the limit can apply to each term right now. So for the first term, it's a constant. For the second term, it is a what? 3 over a large number, but in terms of negative, but still a large number, so it goes to 0. Okay, over, and this one, don't forget that you still have negative, right? So square root 1, okay, here the limit will goes to 1, and there the limit will be 10 over a large number, so it will be 0 again. So here it is negative 2. Okay, and this one is the one that you will most of you will have a common mistake, okay, because right here at this step, okay, instead of using a square root, x squared becomes the absolute value of x, and then see how the absolute value of x change. Okay, then the thing will be will maybe make you go to the wrong direction. However, you may look at the function itself to see the trends, okay, or the, what should I say, the sometimes it tell you, roughly speaking, what should be the answer. Okay, so this one, a square root always positive, right? And then if you plug in a negative number here, so it will be further negative, right? So it is a negative over a positive, so the answer should be what? Should be negative. Okay, so if you got the positive answer, you should know that, hey, something's wrong. Okay. All right. So let us stop this video clip right here, and you already learned the techniques like how to find the limit as your x goes to either positive infinity or negative infinity. Okay, so we are going to continue the next topic with the next video clip. Bye bye.